Hello everybody. My name is Luc Jumpertz, and I'm the founder of a small company named Celedev. And what Celedev does is it develops systems for interactive development of applications in Lua on a mobile system, and especially on iOS. And a few of you who were already in Toulouse 2 years ago may remember that I did present a very early state of the project. So today I will not do a full presentation. I will just run into some of the, I hope, interesting aspects of the IDE. But first, what is CodeFlow? CodeFlow is a system that enables instant feedback on real device on iOS for developing iOS and macOS X applications in Lua. Another characteristic of the system is that it brings to the application, to the Lua part of the application, the full SDK scope, which means that all SDK of iOS is available from Lua, which means that you don't need to it does not restrict what the application can do on the device. And finally, we try to implement as powerful development tools as possible, just to provide the best possible developer experience for our customers. And the expected benefits of this kind of technology have been already mentioned on the default presentation, because it's almost the same IDE. It's by enabling a faster development cycle, you can provide better creativity on the developer side, just because the developer can experiment so much quicker than with the classical development, when each time you change something, you need to recompile and reload the application on the device. And at the end, you get a better application user experience, which is the final goal. So, on the technical side, CodeFlow is made of two parts: the IDE that runs on the computer, and the Lua CodeFlow runtime that runs inside the iOS application. So the Lua CodeFlow runtime includes the standard Lua state, one or several Lua state, plus some logic for monitoring this process and making the bridge to the iOS library. So let's zoom a little bit on the IDE. So this is a classic IDE from the outside. We have a 4-pane display whose main part are the code editor. As you may see, it is much colored. The project editor, where the source file of the project are. In the project editor, we have the binding library, which are available, that I will mention later, and especially specialized bindings for the project that are dynamically generated. And we have a full featured debugger that helps to analyze and investigate problems in the application. So let's start with the editor. So most editors these days implement some code-specific feature, like code coloring, like automatic indentation, some level of code completion, and so on. But all editors are not the same. There are basically two types of editors. The most spreaded one is the standard editor, who manage the code aspect purely as text, meaning that for these editors, managing a code programming language is having a file or a set of files that describes a number of textual features of the language. And often it's in the form of regular expressions or list of keywords, so sometimes simple text macro. It's macro processing basically. But this works not so bad, but the editor has no real knowledge of the program structure. So it means that it just blindly applies the regular expression to calculate things in the code, and so the feature set is really limited, and adding more intelligence in this kind of editor requires to develop either real complex regular expressions, which are costly in terms of performance of the IDE, or that make it clearly not possible for certain situations. By chance, there is a second type of editor, which are the what I call the syntax-driven code editors. Syntax-driven code editors work differently because they build a full abstract syntax tree for the source code that you are analyzing. And IST have already been mentioned during this workshop, so I won't take long to explain what an AST is, but you can think of it as a logical representation of the structure of your source code. And what do we need to make an AST work in conjunction inside a code editor? We need just a simple thing, just that each node in the AST stores the associated character range or byte range that correspond to this node in the source code. This way, for a given location in the source code, you can find where it is in the AST, and for any internal structure of the AST, you can make the correspondence with the source code. Obviously, the AST must be kept in sync with the source code. But this is not an issue because generally typing is rather slow. And even if you have a very fast typing, making this syntax tree generation in the background is enough just to hide all the time for you. And so syntax-driven code editors have a number of advantages, meaning that the editor gets the full logic of the program, and so can do much more powerful stuff and accurate stuff than the text-based processing. So let's go into a small demo. Okay, so here we have the editor. So what can we see in here? So compared to the other code samples that we have seen, where we have many colors here, and colors are not there just to make a pretty display, they bring information. For example, we can distinguish local variables and up values. We have the global variables that can be highlighted in a different color. And that make, when you develop, you get information. For example, when you type and you mistype a variable name, having the global color appearing make that immediately visible, and you can fix the thing. Second example of what a syntax editor can bring, it's syntax selection. If in the syntax editor I can make selections that will respect the language syntax. For example, if I double click on a word, I will select a token, that's normal. If I triple click on a given line, I will select an instruction, and if I move my pointer here, the selection will be adjusted just for the enclosing syntactic structure of the language, so that if I cut or paste this, I always copy or paste consistent entities. For example, if I go there, I have the full function that is defined. And I wanted to show you third example. So this is a small code in Lua that is named local masking madness, just because it does not do anything useful, but there is a lot of masking of local variables and definition of local environment in this program. And the issue with this kind of code is how can you manage who is who in the program. And here, again, the editor can help you. For example, let's take a difficult subject, the Lua environment, which not many people use every day because it always appears a little bit exotic. And finally, when you understand how it works, it's really simple and elegant. But an help from the editor for this is can help. For example, let's take this local amp that copies the a reference only to the map library inside the amp. If I double click in this guide, this map inside, we can see highlighted the uses of the map variable inside the amp. And these users also include the literal declaration table and other stuff. So this gives great information about this. Let's take a different example. For example, if I select this one, we have environment hiding, and so a p variable with 2i defined inside this. P is defined here. It's used here as a free name, as a global variable. It's used here as a field of the amp table, and it's used here in both cases. And this helps bringing a feature like variable renaming. If I move to renaming mode, I can just change the name of all of them at the same time. And so this brings some comfort for the developer that cannot be provided by text-based editors.
Excuse me.
Yes?
Will this go across multiple source files?
This is this variable renaming currently is only inside one source file because it focuses on what's inside the file, because each chunk is independent in Lua, so you cannot know whether in a different source file it will be the same thing or not. But I'm thinking about making some refactoring of names across the full source project.
Oh, sorry,
Yeah.
you started off modifying pi, I just realized, but I was wondering why it didn't change math.pi as well, but that's because it started off.
Which one?
Yeah, it started off as PII. I was wondering why it didn't change just math.pi.
Mm-hmm. Sorry, I didn't get your question. Was that the question? Actually?
No, not really. I just wanted to see if you delete the I and then try and do it again.
Yeah.
Will it change the math.pi in the. Yeah, so that now, like, click somewhere else, redo it, and then I want to see what happens.
Where? What? Here? It will be exactly the same.
Okay, and then, so then my question was, how does it know that the math.pi in that table constructor is different?
Yeah, because it does not have the same role in the syntax tree. Because this one is the name of a field reference, and this one is an expression that is allocated, that is assigned to this field. So they both have a different role in the syntax tree. So from a text point of view, both strings are the same, but from the syntax point of view, both strings are totally different. And you cannot mix both. For example, these pies here with 2i were not affected when I change the pi in there. Just this is what a syntax-driven IDE brings, basically. So this is quite an extreme example, but the goal of all this is to bring a consistent experience across all types of syntax editing inside the IDE. Okay. Back to the slide. So we have seen that an advanced syntax-aware Lua editor can be of some help for the developer. And a few words about how the syntax tree is built, because there are many possible strategies in this regard. If you have a look at luauser.org, you will see a number of articles about the syntax tree building. We have adopted a quite original approach, I think, which is we based our 3 generations on the standard Lua file, which is ls.c and lparser.c. And of course, we have slightly modified these to add a few features, but these were really small changes that did not affect the working of this file. The advantage of this is that it brings good performance because the Lua parser has been designed to be executed quickly, but more important, it guarantees that the editor and IDE have the same understanding of the language than the Lua runtime that we run inside our application. And that's a key point because any language, even if you consider the grammar as it's written in the spec, has a few corner cases that we want to handle the same way as Lua does. So this is available as an open source project, at least for the low level, meaning the changes in lecture parser. You can download it if you want. Okay, second part, debugger. The Lua debugger is a big topic. A number of speakers that talked previously told, hey, we use no debugger, but you know with Lua this is okay, because code is so simple. We had no problem with that. But anyway, it's a bit annoying to still continue to debug program with print and traces. And this always makes me sad. Because having good debugger makes the bug fixing so much easier, provided that the debugger has a certain number of qualities. And so one of the qualities must be easy to use and well integrated with the rest of the IDE, so it's simple. A very important quality is the debugger must be fast and have a very low overhead. Means that if your debugger slows down your program by a factor of 2, you won't use it, obviously. If you almost cannot notice that the debugger slows down the program, you will notice all the time. We will use it all the time. And this is actually what we do in CodeFlow. The debugger is always out. It means that when you're running your program, if something bothers you, you just put a breakpoint at some place, and then the program stops, and you can examine the variables. So features of the debugger. Nothing mysterious here. Step-by-step execution and breakpoint. Important feature, what if a runtime error occurs, you want to stop in the debugger and can examine the state just to see what were the cause of the error and fix it on the fly if possible. Even if you can continue from the runtime error, it's even better. And you need also to inspect totally the state where you are stopped. State include all the call labels, the stack frames of your call stack in the current thread. And this variable inspector shall display obviously what the Lua debug API provide, meaning the parameters, the local variables values, but also shall enable just to unfold what can be unfolded if you have a table or a C struct or any value that you want to examine inside, you shall be enabled just to dig in. And here you can see the variable inspector, and with the variable on the left with their names and rows and types, and here on the right the types of the variable with the values. All gray type are type that come from the C row. That's by convention, but you see that the type, the CGREC type, which is the basic type on Cocoa, you can examine what's inside, like any other Lua type. Okay, stack aware command console. This is important, meaning that when you're stopped, you want to run any chunk of code of any kind in the current context, meaning like not the Lua editor by running a new chunk and having no access to the local variable. You want to have access to everything that the code provides at the stop, at the point where you stop. So we provide this as well. and also a subject, interesting subject is multi-thread debugging. So debugger in CodeFlow is multi-threaded. Multi-threaded means that if you have several Lua threads active at one given time, you can examine each of them independently. So you may say, hey, but there is no thread in Lua. So, yes, there is coroutines, obviously. So I will show you in a minute how you can debug a program with coroutine and see all threads involved in the coroutine at the same time. And in our target system, there is also Lua can be called from multiple threads at the same time. So CodeFlow implements a kind of multitasking that enables these calls to be done from multiple threads, but only one at a time. And so multi-threading works. So back to the demo. For this demo, we'll go to a small program named coroutine iterator. I think I've taken this in from programming in Lua, I'm not sure. So let's start debugging it. I've set a number of breakpoints on the side to be sure to stop at the right point. So let's start. So we execute the program. Here it's executed in the local Lua context. We have no iOS device involved. And so we start in a for loop. Let's step. So we see here we have a thread named thread2 because I have no better way of naming thread for now that and the local variables at this time. We can step into this program. So let's continue. Step into, we create the coroutine. We see an object named CO with a thread type that appears. Name is thread3. Let's continue to step. So we are in the iterator function. We step in coroutine resume, and then we are in a different thread. Thread 3 has been launched, and we are in the function which is here, the coroutine function. And we can still see the thread here, and we can still examine the current state of this thread. If I move to here, I have can see the point where this was. So, and if we continue, we run this. Okay, we call recursively, and we may enlarge the window on the bottom. Okay. And now, so go to PermGen, and now we arrive on the yield. What will occur when we yield? We just here switch back to the other thread, and we see the code, the result is true, which is what we expect, no problem, and the result has been propagated. And our first thread, our yielded thread, we see it's waiting on the yield function, and so we cannot continue it because it's not stopped yet. Okay, so that was it for the debugger demo. Third topic about the module management. So I will go faster on this one. So managing different source files is a classic role of an IDE, and CodeFlow is an exception to the rule. So logical choice for me for managing interaction and dependency between Lua modules is to use the require function. And the require function does exactly what we need. It means if the module code has not been loaded yet, load it and execute the main chunk function and store the result, and if it has already been loaded, reuse this result and just return it. However, in CodeFlow we have a slightly different need, just because we have our Lua modules on the Mac in the IDE space, or you might imagine the Mac file system, and the require is run inside the application on the device. So that has no access to this file system. So the require as it is now was not really convenient for us, so we have just rewritten it, which was not very complex. and we have tried to keep the behavior as much as possible. However, we have done two small changes inside. First one is to enable multiple return values from chunk, which is not complex, but which brings more freedom and more transparency when you require the module the caller just get back what the callee returns. No problem with that. And another change which is related with our auto reload code feature is that if a module changes in the IDE, we want it to be reloaded on the device. So it's not a load once, it's a load once until changed. And what does change mean? Change means syntactically change, meaning that if you add spaces or blank lines or even a comment in your source file, it will be considered as not changed. If you change a value or add a code structure somewhere, it will be changed and reloaded. Last feature I wanted to speak about, don't know, we have small time, we were in advance, is automatic binding generation. Why automatic binding generation? Because in the target application, the Lua code interacts quite heavily with the C and Objective-C API, because the Lua is just called as part of a bigger scenario. And so the Lua part of the application need to access to the system SDK, to iOS SDK or macOS SDK, but need also to access to any custom API that is used by the target application. If the application uses a third-party framework, the Lua may want to access to this third-party framework. If the application defines some internal API that it wants to expose to the Lua part, it shall do so. That's why CodeFlow generates project bindings on the fly for all the API defined in .h file of the Xcode project of the application. You will know Xcode is a development system provided by Apple for the systems. So, maybe a quick demo of this one. So for that we will switch to a small Mac application which is here. So this is a Hello World application that displays a Hello World on a curve, on a circle to be exact. So I will open from CodeFlow the associated Xcode project. As you can see, the Xcode project is quite small. Everything is done in Lua in this, but we have already, nevertheless, an empty view controller defined that does nothing, but is there to be extended as a class by Lua, but I won't talk about this. So if I run the Hello World Mac on the project to compile, I click twice on it. So here we have this little icon bumping, just because in CodeFlow we are stopped on the breakpoint at the beginning of the project. So if we wanted to do step by step, we could, but for now we just continue. And see, here is the application which just draws text on a curve and that reacts to the window resizing. So, and just you can see that when I resize the window, you have a small LED indicator on the top of the screen here that indicates that we have Lua activity. If I move it, you see this small indicator blinking, and as soon as I stop it, this is the application monitoring from the IDE. So let's have a look on the bindings, project bindings. So we have two H files in our Xcode project. We have unselected one because we are not interested, and the other one, for now, as a simple empty class declaration on the C side, and this has caused the generation of a simple Lua binding that declares the class for the Lua side. What we want to do now, we want to add some more C interface in the project. So we go to the viewcontroller.h. Okay, I have 2 code snippets to make things quicker. So this defines a C struct with 3 fields. This curve coordinate, we have the position on the curve, we have the rotation angle, and is it above the curve or not, which is a Boolean. And we have a C function which says curve coordinate convert to point. So the name is rather long, but this will enable this too. So we will get this name in the Lua context more easily. So I also need to add the implementation of the C function in the .m file, which returns just a constant point for now. And I can switch back to the project. We can see this small running indicator that was indicating that the bindings were regenerated. We have also an alert that says, hey, we have added a new library to our Xcode project. You should rerun it because it's the compile word. And our bindings file is now much more complex. It integrates the definition of the structure with the indication of the fields. It indicates a constructor for the structure, and the C function has been converted to a struct method. So we can rerun the application from Xcode. We stop it. It's been recompiled and rerun. And so here it's still working. Now, we'll just to demonstrate that it works, I will add in this function the access to this C structure. So let's say we define a chord variable, which is a struct point. The name was curve something. I tap curve, the auto-completion brings me the C name immediately. So there is no issue with that. And so constructor takes 3 parameters. Let's say 100 math.p and a Boolean, and so I think that's it. So I will reload the function, the code, and if I need to put a breakpoint just so that we check what's going on. So if I move my window, I stop on the breakpoint, and let's have a look at what we have in the debugger. So we have a long list of variables here. If I step over this, we see the code variable, which has the correct name, and I can open it and see the value of my field that was defined in C immediately. So this brings, the idea of this is to bring a as transparent as possible interface between the native part of the application and the Lua part. Okay. So we have seen this, that not only bindings are automatically generated, but they are integrated in the IDE during this generation. If you're interested, the binding generation is based on Clang as well. I have no time to enter to the detail, but I will be happy to discuss it later if you want. So, as a conclusion, I would say that the real value of an IDE really comes from the integration of its components. And the question is, why would we need an IDE for Lua? But a dynamic language like Lua comes with specific challenges like the absence of typing, which is a good thing at certain steps of the project, and that can be a more difficult thing at other steps, and the auto-declaration of variable, and a good IDE can help to this. And this is only the beginning. I have not written this on the slide, but we have lots of things in the pipe, and especially we have in the project to add more type inference inside the Lua code so as to detect in simple case, but most use cases are simple, the mistype variable problem between Lua and the calls of the API which are typed in C before the execution. And I think that's it. Thank you for your attention. Any question?
Will you have any plans for like plugins, so like you use things like Lua Chain or other stuff like that? And so that you can also integrate, Lua Chain could do some of the things you mentioned, the use of globals and stuff like that.
Yeah. No, we have no plan for that. The kind of plan we have is to integrate more and more tools in the IDE, but to use the foundation that we have, which is a quite solid foundation with the IST-based stuff, and to leverage that just to build more and more features.
But if you the power tools to link JavaScript, yeah, because it's a reference, is that you can use the same tool, whatever IDE you use. And this allows me to write a set of rules once, and then use it, whatever my syntax use. So,
yeah, but I think this is a different tool. I think this is perfectly valid. Both approaches are perfectly valid. But
I'm not for Lua Chain,
yeah.
but if you want to use your foundation, okay. But do you want to maybe publish this for foundation's library and then create a tool that would be able, we would be able to run?
I don't know yet. Frankly, there is no project for now. This is a specialized IDE, and I was showing it not to sell it, but more as an example of what an IDE for Lua can do. And part of it may be open source, but almost everything is written in Objective-C. Not all people like that, so I'm not sure this is interesting.
Do you use Metal Lua in some way?
Metal?
Metal Lua.
Metal Lua, no, not at all. Yeah.
Well, you said you use the parser, the Lua parser. So when you make any change in the text, you rebuild the whole tree.
Yes.
You do not change the tree.
No. I rebuilt it entirely. And actually, it's fast.
So
It's
if
fast.
there is any error in the middle, so you keep just the tree up to that point.
There are some tricks there. In fact, if by using the Lua, actually the syntax tree stops on that error point. But actually, we keep the last good syntax tree, and we try to match the end of the file if it has not changed with what we have in the last good syntax tree, which is indispensable because it allows to have variable completion and the name completion for those things that are defined after the error when you type on the flag.
So you rebuild the tree, but you keep.
Yeah, you keep. In fact, CodeFlow, I think a very original feature of CodeFlow, as it has been designed for dynamic code reloading, it keeps the entire history of what has changed in the file, and it keeps the syntax tree as well.
About generating the bindings, it wasn't obvious to me what happens behind the scenes. It doesn't look like it generates something like Lua CAPI binding or Lua FFI binding. Does this have some kind of like a runtime?
Okay. About the binding process uses libclang, so the LLVM C parser, just to analyze totally the syntax. From the syntax tree in libclang, it generates C code for the bindings, and this C code it generates two things. Actually, it generates Lua code for the IDE for documenting the code and for helping for code completion, and it generates C code for the binding. This C code is compiled as a library behind the scene, and this library is added to the Xcode project. So
and
it's
that's a Lua C binding type of binding. It auto-generates Lua-C binding.
Lua-C.
Lua,
yeah,
Lua-C
Lua.
API type of binding. Not like Lua-JIT.
No. The LuaJIT, in fact, LuaJIT was not an option as we were targeting iOS, so we just dropped it at the beginning of the project.
The code completion that you had there, it found functions and so on.
Yeah.
Are you intending to add also so that it will give you the parameters? And
Yes.
yeah.
Yes. Definitely. Yes, this is an improvement that we have in the pipe right now.
And when you require in modules, will those try to fetch the functions from that and code completion?
Yes, exactly. The code completion works by fetching the dependency tree of the current source file and try using all the modules required by this module, all modules required by this record modules, and so on. Yes.
We'll also try to figure out what is return for functions when it comes to autocomplete.
I'm sorry?
We'll also try to figure out what is return from functions when you do it. So can you figure out what always a table is returned?
Currently not. Currently the return type are documented in the binding but not used. Was that what your question or?
No, I'm thinking the AST if you can figure out the
Yeah. You mean if a function has multiple return value, can it figure which goes to which parameter?
yeah, and can you figure out if it returns a table?
Currently, I don't. Currently, we don't. We plan to do it, but it will work only for function with consistent return types. You know, if one function returns nil in some branch and the 3 parameters in different branch, it's not. There is no way you can type this in.
No, of course not. But if there's only one branch.
Okay.
So, Lua syntaxer is the library that builds the abstract.
Yeah, Lua syntaxer is the low level stuff that builds this abstract syntax tree. In fact, it's a C library. It's not Objective C, it's pure C based on the Lua parser, and it adds a kind of callback mechanism to the Lua parser, and each callback corresponds to a node in the syntax tree. And so the callback has ordered in a certain way that the building syntax tree on the record level is easy.
So, which ways did you compare to other libraries that does kind of stuff? I remember I got an IDE for Gibbs, that had some libraries to perform this kind of stuff. Did you compare with those?
I did not compare actually how the library what were performing. We choose this approach of using the Lua parser just for guaranteeing the complete consistency between what the IDE sees and what the application executes. And a third-party parser based on the grammar may introduce slight changes in the way the Lua grammar is interpreted. For example, let's take a simple example. In Lua, if you insert a do repeat until instruction inside your code, you can use the local variables defined inside the block in the until condition. That's not easy just to utilize for a syntax tree builder.
So, otherwise, you manage those corner cases?
I think they should manage it, but I have no guarantee that they do. And the advantage of our approach is that when the new Lua version comes, we just use Git to merge what we have done with the new Lua version that comes, and we have done this twice or 3 times in the past, and it was really easy.
Does this IDE have integration with version control?
Not directly in the IDE, but all the programs shown you are under GitHub, and so it works with this version control completely transparent. In fact, behind the scene, when you save your project, is it's a tree of file subdirectory, so you can put the internal GitHub product.
More questions? Thank you.